Mercury vapor, metal halide, and high-pressure sodium lamps are distinct lighting technologies and cannot be directly interchanged. Mercury vapor lamps operate by emitting ultraviolet light. A phosphor coating inside the lamp converts this ultraviolet radiation into visible light. A specific blend of phosphors determines the color characteristics of the light produced. Metal halide lamps generate light through an electric arc passing through a mixture of metal halides and gases. The composition of these halides dictates the color and intensity of the light. High-pressure sodium lamps vaporize sodium to create light. This process results in a characteristic orange-yellow light. Crucially, these lamps differ in several key performance characteristics. Firstly, spectral output. Each lamp type emits a unique spectrum of light, meaning the distribution of wavelengths and colors varies significantly. This difference affects how objects appear under the light. Secondly, efficacy refers to the light output per unit of electricity consumed, typically measured in lumens per watt. High-pressure sodium lamps generally exhibit the highest efficacy, followed by metal halide, and then mercury vapor lamps. Thirdly, the color rendering index, or CRI, measures a light source's ability to accurately render colors compared to natural daylight. Higher CRI values indicate better color rendering. Mercury vapor lamps typically have lower CRI values compared to metal halide and high-pressure sodium lamps. Fourthly, wattage. Each lamp type is available in a range of wattage ratings, which determines the power consumption and light output. Substituting one type of lamp with another can lead to a variety of problems. Color mismatch can occur due to the differing spectral outputs. This means the color temperature or CRI of the replacement lamp may not match the existing lighting scheme, resulting in an inconsistent or undesirable appearance. Brightness differences are also likely, as the light output levels of different lamp types vary even at similar wattage ratings. This can lead to areas that are either too bright or too dim. Potential compatibility issues arise because each lamp type requires a specific ballast to regulate the voltage and current. Using the wrong ballast can damage the lamp or the ballast itself, and may even create a fire hazard. Physical dimensions of the lamps may also differ, preventing a proper fit in the existing fixture. Safety concerns are paramount. Mercury vapor lamps contain toxic mercury, requiring special handling and disposal procedures to prevent environmental contamination. If a mercury vapor lamp breaks, it can release mercury vapor into the air, posing a health risk. Due to these significant differences and potential problems, it is essential to select the appropriate lamp type for a given application and to avoid direct substitutions without careful consideration and modifications to the lighting system. In summary, these lamp types are not interchangeable due to differences in how they produce light and their performance characteristics. Attempting to substitute one for another can result in color mismatch, brightness differences, compatibility issues, and safety hazards.